Hello, this is Owen Chai from Eneroc. Today's training will cover understanding lithium batteries and after-sales service education. The contents of the training material include product introduction, internal components, battery pack structure introduction, maintenance and repair, safety precautions, and finally, common defects and maintenance with troubleshooting. First, let me introduce and explain our product. There are two main types of lithium batteries, lithium NMC and lithium iron phosphate batteries. Lithium NMC batteries are primarily composed of nickel, manganese, and cobalt, while lithium LFP batteries consist of iron and phosphate. Therefore, understanding that both are lithium batteries. Now, let's look at the advantages of each battery type. Regarding battery lifespan, NMC batteries have around 2,000 cycles, while LFP batteries have around 4,000 cycles, making LFP batteries last longer. In terms of safety, while NMC batteries undergo thermal runaway at 200 degrees Celsius with rapid heat dissipation, LFP batteries undergo thermal runaway at temperatures exceeding 800 degrees Celsius and demonstrate slower heat dissipation compared to NMC batteries. From a pricing perspective, NMC batteries are composed of expensive raw materials, resulting in higher price volatility, whereas LFP batteries have abundant raw materials, resulting in less price volatility and lower costs. Although the charging speed is the same, LFP batteries are recommended to be charged at around 0.5 C to 0.7 C for lifespan protection. Lastly, in terms of energy density per unit weight, NMC batteries are approximately 50% higher than LFP batteries. Therefore, it can be concluded that for forklifts or commercial vehicles, applying lithium LFP batteries is a more rational choice. Lithium LFP batteries consist of 5 components: cathode, anode, electrolyte, separator, and cover. Now, let's discuss individual cell batteries. The rated voltage of a lithium LFP battery cell is 3.2 voltage, with a lower protection voltage of 2.5 and an upper protection voltage of 3.65 voltage. The rated capacity of each cell is 150 amperes, resulting in a total energy capacity of 480 watt. Next, let's look at battery modules connected in series and parallel. Connecting multiple cells forms a module. First, let's examine the battery module connected in series. It consists of 5 single cells of 3.2 voltage 150 ampere connected in series. The total voltage is 16 voltages, and the total capacity remains at 150 amperes, resulting in a total energy capacity of 2.4 kilowatt. Now, let's consider the battery module connected in parallel. Similarly, it consists of 5 cells of 3.2 voltage 150 ampere connected in parallel. The total voltage remains at 3.2 voltage, but the total capacity increases to 750 amperes. Therefore, the total energy capacity remains at 2.4 kilowatt. As such, it can be understood that connecting cells in series increases voltage, while connecting cells in parallel increases capacity. When battery modules are connected, and housing and a battery management system are incorporated, it is referred to as a battery pack. The total voltage of this battery pack is 51.2 voltage with a total capacity of 304 ampere, equating to a total energy capacity of 15.565 kilowatt. It is evident that this battery pack comprises 16 individual cells connected in series. Now, let's delve into the electrical principles of the battery pack. The following diagram represents the internal and external electrical circuitry of the battery pack. Please refer to it if necessary. Next, let's examine the heating conditions during battery discharge. Firstly, when using the battery, heating begins when the module temperature is below 5 degrees Celsius and stops when it reaches 10 degrees Celsius. Secondly, heating is not allowed when the module temperature is below -10 degrees Celsius and SOC, state of charge, is below 20%. Thirdly, heating is permissible when the module temperature is below -10 degrees Celsius and SOC is above 20%. Fourthly, Heating during discharge is possible when the module temperature is between -10 degrees Celsius and 5 degrees Celsius. Lastly, if the module temperature is above 5 degrees Celsius, normal discharge occurs without heating. Precautions during discharge heating. Heating is not allowed when the temperature is below -30 degrees Celsius. Heating is not allowed if the heating time exceeds 8 hours. Heating is not allowed if the internal module temperature exceeds 25 degrees Celsius, indicating a junction error. Secondary heating is not permitted. If the vehicle is left idle and the temperature drops again, the battery power must be turned off and restarted for heating. Heating is not allowed in case of BMS communication failure or hardware failure. Heating is not allowed in case of stuck discharge relay. Next, let's discuss the heating conditions during battery charging. Heating occurs under the following conditions: no charging below 0 degrees Celsius. Heating starts simultaneously with charging when the module temperature is above 0 degrees Celsius. Heating stops and charging continues when the module temperature reaches 12 degrees Celsius. The specifications of the heating pad are as shown in the left table. Precautions. Conditions 1 to 3 are similar to those during discharge. For secondary heating, reconnect the charging plug. When necessary, conditions are met. Heating is not allowed if the voltage of individual battery cells is below 1.8 voltages. Now, let's examine the structure of the battery pack. As shown in the picture, there are two modules inside the battery pack, M1 and M2. You can see the communication lines and heating lines of each module on both sides. On top of each module, various components are installed. From left to right, there is the BMS developed by Eneroc, a DC-DC converter that converts high voltage to 12V output voltage, and other components such as shunts, heating and discharge and charge relays, and fuses. Each module is connected by a busbar, and it can be seen that the total cathode busbar of module M1 and the total anode busbar of module M2 are connected in series. Now, let's discuss the main functions of each major component. Firstly, the heating relay controls the heating pad. Secondly, the charge and discharge relay, which has integrated control functions during charging or discharging. Thirdly, the DC-DC converter converts the battery's input voltage to a 12-voltage output voltage and supplies power to the BMS. Fourthly, the shunt serves as a current sensor. Fifthly, the fuse provides protection against short circuits and overcurrent. Lastly, the BMS acts as the brain of the battery pack, performing functions such as logic control, voltage measurement, temperature measurement, and error protection. Here are the types of relays and their photos. On the left is the heating relay, which controls the heating circuit to regulate the heating pads. On the right is the charge and discharge relay, used in the charge and discharge circuit to control the charging and discharging of the battery. Next is the photo of the DC-DC. The DC-DC converts the high-voltage direct current of the battery pack into 12 low-voltage direct current to supply power to the BMS. Following that are the photos of the shunt and fuse. The shunt is used to measure current by generating voltage at both ends when DC current passes through it. The fuse is a protective device that prevents overcurrent by self-heating when excessive current flows for a certain period of time. Here is a photo of the BMS developed by Eneroc. The BMS serves as the brain of the battery pack, monitoring battery status and external conditions in real time, recording, diagnosing, and issuing warnings for voltage, current, temperature, controlling charging and discharging, charge control, balancing, and thermal management. The BMS prevents overcharging and overdischarging of the battery, thus extending its lifespan, and most importantly, ensures safety. Next is the photo of the charging plug. The DC plus and minus port is the port for supplying power to the battery during charging. The A plus and minus port, located in the center, supplies low-power 12V output to the BMS. Lastly, the S plus and minus port at the bottom center is responsible for charging communication between the battery and the charger, allowing control by the BMS. Now let's discuss battery maintenance and management methods. First, let's look at precautions when using lithium batteries. Use protective equipment that meets insulation standards when performing electrical work on lithium batteries. Avoid prolonged exposure to temperatures above 55 degrees Celsius. Do not allow the battery to come into contact with water or other conductive liquids, and avoid direct contact between the positive and negative electrode plates of the battery. Keep the battery away from corrosive chemicals or hazardous equipment, and away from hot and humid environments. If smoke or a burning smell is detected during use, immediately disconnect the power and use a high-pressure water or carbon dioxide extinguisher for mitigation. The next precaution is periodic connector status checks. Since the charging port is exposed externally, it is recommended to clean off dust once a month. Also, regularly check if there is any heat or discoloration on the charge and discharge cables and if there are any signs of burns on the copper electrode plates, and replace them immediately if any issues are found. The third precaution is for the winter use of lithium batteries. The heating condition of the battery pack requires that SOC be maintained above 20%, and heating occurs even at temperatures below -10 degrees Celsius. Note that if the temperature drops below 0 degrees Celsius, it is normal for the performance of lithium batteries to degrade, but our battery pack automatically activates the heating function as heating pads are attached to each module. Additionally, after a certain heating period, if the module temperature exceeds 10 degrees Celsius, the heating mode will be discontinued, and normal discharge mode will resume. Fourthly, let's discuss precautions when using the vehicle or during battery discharge. When using the battery, it's essential to charge it under the following conditions. First, when the SOC reaches 20%. Second, when the total voltage and over-discharge alarm are displayed on the battery display. Third, when each cell voltage and over-discharge alarm are displayed on the battery display. Additionally, if the vehicle is left unused for more than a day, it should be fully charged before use. If the maximum temperature of the battery pack during discharge is too high, usage should be discontinued. If there is a burning smell, immediately disconnect the power and contact the engineer. Fifthly, let's look at precautions during battery charging. Firstly, ensure that the charging plug is correctly connected to the battery. During charging, if you need to remove the charging plug, always turn off the charger first before unplugging it from the battery. Lithium batteries should be fully charged at least once a week to balance the voltage and capacity between cells. Lastly, if a burning smell is detected during charging, immediately turn off the charger, unplug the plug, and contact our engineer. Next, let's check safety precautions. When working with batteries, it's essential to wear insulated shoes and insulated gloves. Tools required for lithium battery maintenance include insulation sleeves, insulation wrenches, laptops, and USP can analyzers. Please refer to the shipping requirements for battery pack shipping and transportation. Next, let's talk about the storage requirements for battery packs. Batteries should be stored at a state of charge, SOC, between 40 to 60%. Avoid storing batteries near flammable and explosive products or corrosive chemicals. Ensure that the storage area is free from strong external vibrations, shocks, or magnetic fields. Also, protect the batteries from direct sunlight, install warning signs, and equip with alarm devices and firefighting equipment. Lastly, it's recommended to fully charge the batteries if the storage period exceeds 3 months. As the fifth safety precaution, let's discuss the manual for long-term parking and abandonment of vehicles. If the battery is left unused for more than 10 days, maintain the SOC of the battery between 60 to 70%, ensure that the battery power is turned off, maintain a distance of at least 2 meters between vehicles, and park indoors or in a waterproof location. If the battery pack is left unused for more than 20 days, check for normal charge and discharge operation. Lastly, if the vehicle is left parked for an extended period, it's advisable to regularly check the data from the BMS for any faults. Lastly, let's discuss the procedures in case of a fire or collision accident. In the event of a fire, first evacuate the scene and call 911. Then, secure personal safety and extinguish the fire using a fire extinguisher, high-pressure water, or sand. If you accidentally inhale smoke or suffer burns, seek medical attention immediately, and consult the dealer for vehicle disposal. In the event of a collision accident, turn off the vehicle's power, visually inspect for exterior damage, contact our service department, and refrain from restarting the vehicle. Finally, let's discuss the causes of battery fires and thermal runaway. There are three main factors: mechanical abuse, overcharging, and overdischarging. Firstly, mechanical abuse involves external impacts that can deform the battery pack, causing the battery separator to tear, resulting in internal short circuits and potential leakage of flammable gases, leading to a fire. Secondly, overcharging the battery can cause a rapid increase in battery voltage, generating a large amount of gas inside the battery, raising the temperature and internal pressure rapidly, posing a risk of explosion and fire. Lastly, overdischarging the battery can be fatal. Overdischarging increases the internal pressure of the battery and separates lithium from the negative electrode, increasing internal resistance and reducing battery capacity. As the final content, let's discuss general troubleshooting methods and maintenance-related troubleshooting. When checking for faults inside the battery, you would typically use a multimeter as shown in the picture. Set the multimeter to the ohm gear and press the orange button on the right to display the waveform. Then, touch the red and black pins to see if the signal sounds. If it does, it indicates correct selection. Now, let's discuss how to determine faults in pre-charge resistors. Set the multimeter to ohm gear and measure both ends of the resistor. If a specific resistance value is accompanied by a beep sound, it indicates that the resistor is in good condition. Conversely, if the display shows OL and no sound is heard, it indicates a fault in the resistor. Next, let's discuss how to determine faults in the DC-DC. Set the multimeter to DC gear and connect the two pins to the DC-DC output terminal to measure if 12V is outputted. If 12V voltage is observed, it's considered good; otherwise, if any other voltage is detected, it's deemed faulty. It's important to check for a steady and consistent output for about 30 seconds when measuring the output voltage. Next, let's discuss how to determine faults in relays. Set the multimeter to ohm gear and measure both ends of the relay. If the display shows OL and no beep sound is heard, it indicates that the relay is not stuck. However, if a beep sound and resistance value are observed, it confirms that the relay is stuck and needs attention. Lastly, let's discuss how to determine faults in fuses. Similarly, set the multimeter to ohm gear and measure both ends of the fuse. If a specific resistance value is observed along with a beep sound, it indicates normal functionality. However, if the display shows OL and no beep sound is heard, it indicates a fault in the fuse. When checking the battery, it's important to take photos like this to keep records and reference when reconnecting the wire harness after inspection. Same as above. Finally, let's discuss the battery pack disassembly and reassembly process during battery inspection. To disassemble the battery pack for inspection, follow these steps. First, turn off the vehicle's power. Next, remove the battery box and vehicle communication harness. Disconnect the vehicle's power cable. Then, carefully remove the top cover without disturbing the wires, and take note of the wire positions inside the battery box. Next, remove the main positive electrode plate and wrap it with insulating tape. Similarly, remove the main negative electrode plate and wrap it with insulating tape. After inspection, reassemble the battery pack in reverse order. Now, let's move on to troubleshooting that can be referred to in case of the following faults. The first common fault is, the display panel of the battery does not work even when the vehicle power is on. The second is, charging failure. Continued as, charging failure. The third is, relay adhesion fault. The fourth is, relay connection fault. The fifth is, insulation fault. The sixth is, abnormal voltage difference. The seventh is, abnormal SOC, state of charge. The eighth is abnormal feedback current. Lastly, abnormal temperature fault. That concludes the introduction of Eneroc batteries and A and S training. Thank you for listening.